Hi, my name is Ido. Thanks for taking some time out of your evenings to join me for this tech talk. What we're going to cover is how to set up a virtual private server on DigitalOcean. And this is a way that you can basically host your own website on the cloud. Now, a lot of words there that I definitely needed to look up when I first started researching some of this stuff. So a virtual private server, for those of you that don't know, you can think of it as just a computer that somebody else is managing for you. And in this case, that somebody else is DigitalOcean. And DigitalOcean is a cloud provider, kind of similar type of business that like Amazon, AWS is in, Google Cloud Platform, Microsoft Azure. These are all just different cloud providers. And so what they're doing is basically making different services available to you on the internet. A little bit about me. So I finished launch school's core curriculum last year, currently in capstone. Prior to launch school, I had no experience with any of this, so never used Linux, never tried to host my own websites, and I also never had experience giving presentations, certainly no presentations with live demos. Thankfully, it doesn't appear that experience actually helps with live demos. So if things go wrong, I guess I'm on an even playing field there. So hopefully they won't, but maybe we'll have some fun live troubleshooting as a part of this. So here's what we're going to build. We're going to have a virtual private server, this computer that's hosted by DigitalOcean, and it's going to be able to serve a website that we've built. And to do that, it requires a few different components. And I know that in launch schools, I think around the 170 or 180 course, they talk about a server being a very overloaded term, and we're definitely going to run into that here. So we're going to have the virtual private server. That's the computer that's being hosted for us. And then we're going to have a few other types of quote unquote servers that are running on this machine. So one of the first components that we'll be setting up is the firewall. And you can think of a firewall as kind of like a bouncer for network traffic. So we're going to tell it, hey, you can let this type of traffic in, keep everything else out. And the traffic that we're going to enable is something called SSH, which is a secure way to connect to another machine's terminal, which is how we're going to interact with our virtual private server. And then we're also going to enable HTTP and HTTPS. And so that's the way that different browsers will actually be able to hit our website. After that, we will put up both a web server and a reverse proxy, kind of this all-in-one thing. It's called Nginx. And what that's going to do is once traffic has made it through our firewall, it's going to hit this web server. And that web server is going to say, great, you're trying to go to www.whatever.com. I know what you're looking for, and I'm going to route your request to the appropriate app on this machine. So it's kind of another traffic cop manager that's going to be able to handle requests and point them to the appropriate process on our server. One thing that we're going to do to configure this is set up an SSL certificate. And what that's going to let us do is actually encrypt traffic to our server. So it will enable HTTPS traffic in addition to HTTP, which is a super easy thing to do now thanks to this organization called Let's Encrypt and a service that they've created called CertBot. So from what I understand, getting something like that up and running used to be a very both expensive and painful configuration nightmare, but thanks to this organization, it's both free and easy. So those are some nice traits. And then finally, after we've done all of that configuration work, we're going to be able to actually run our website. And to do that, we're going to use a process manager called PM2. And the benefit of doing that is that rather than us needing to manually start the process that's going to serve our website, so in this case, we're just going to have a very simple Express app in JavaScript. Normally, if you're developing locally, you have to do something like running npm start or node app.js. You have to do something to start that process. And that's not something you want to do if you're actually hosting a website on the cloud. You want something to be able to start your process up for you. And that's what the process manager is going to do. If for any reason our server restarts, or if our app crashes because we didn't handle some kind of bug, we didn't anticipate it, PM2 is going to just make sure to spin it right back up again so that we don't have to get notified that there's a problem, remote back into the machine, and then run the right command to start our app up. So to do all this, we're going to go through a series of different steps here and hopefully check our progress along the way to make sure that things are working. So to start off, we're going to create a VPS that we can connect to through an IP address. So I have an account here set up on DigitalOcean, and DigitalOcean calls their virtual private servers droplets. And so in order to create a virtual private server, you have to create a droplet. So you can see here, they make that very easy. It's a nice big button that you can click. So we'll go ahead and start this process. And it gives us a ton of different options for how we want to configure this. As I mentioned before, you can think about a virtual private server as just a computer that somebody else is managing for you. So part of the computer is an operating system, and that's what all these options are. At the very beginning, DigitalOcean is asking us, which operating system do you want us to configure your computer with? I'm most familiar with Ubuntu, so I'm going to choose that here and just choose a more recent distribution of it. And then all of these other configuration options just kind of let you figure out what hardware do you want associated with this. You can see there's a whole bunch of options here. And because I have not built a very sophisticated website, we do not need much very powerful hardware to run it. I'm going to go all the way down to the kind of lowest spec machine here and choose that one. You can choose where the server is hosted, which is nice. I live in New York, so I'm going to choose their New York data center just to decrease the latency here between me and the server. But if you were living elsewhere, you could definitely choose a different data center. There's some additional options related to networking and monitoring that we can ignore for now, but this next section about authentication is really important. And so there's this question mark here that's explaining two different options for how to authenticate with our server. So when we create this server, we want to be able to control access to it. We don't just want anyone to be able to somehow SSH into this machine or log into it somehow and start messing with the configuration. That would be a huge security nightmare. So DigitalOcean provides two ways of signing into this machine. One of them is to rely on SSH keys. And you can see this note down here just specifying that this is a more secure method to authenticate. The other one relies on passwords, and passwords, as keep getting revealed as data leaks just keep coming out, are a little bit less secure. And so we're going to go ahead and choose this more secure authentication method. When we do that, it's going to prompt us to actually give it an SSH key. And this is something that's actually on your computer. It's a way for other machines to identify your computer as being, your own, and then give you whatever access your computer is supposed to have on that machine. So if we click on this new SSH key, DigitalOcean has a very helpful walkthrough that actually explains how to generate this if you haven't done something like this in the past. So if this is something that you want to follow along with, I'll be providing documents like the step-by-step to how to do this. Just a heads up that if you've already generated SSH keys, you probably shouldn't take some of these steps in case they wipe out anything you already have in your folder. I'm going to be following each of these steps right now because I don't currently have any SSH keys on this machine. So there's no risk of me wiping anything out. But if you are going to follow along with this, just a quick warning there that you want to be careful about any steps that might overwrite anything that you do currently have in your machine. So over on the left here, DigitalOcean is asking us for our SSH key and then providing some instructions about how to generate it if we don't already have one. So I'm going to go ahead and just copy this command, SSH keygen, and then I have my terminal open on the left, which is where I'll be running this. So after we run it, it's going to ask us kind of where we want to save the key. And it does provide a default. So you can just hit enter, even though this looks like a prompt. And when you do that, it'll just save it to this default directory, which in my case is just in my home folder for my user. Next, it asks us for a passphrase. Now, this is different than a password. As Dio is explaining here, it's just a way to kind of secure this file specifically, which is something that you probably want to do in case your machine somehow gets compromised. So I'm going to just type in a dummy password here, confirm it, and then you'll see this lovely random art that's kind of indicating that this file was created successfully. And it did two things. So it's going to create both a public key, which is the key that we're going to be providing to our virtual private server. And then on our machine, it's also going to save a private key, which is not something you ever want to give out, but it's what SSH is going to use to actually verify the connection. So if we keep going down here, the last step is to basically give our server that we're about to create the public key that we generated from running this SSH command. So I'll copy that. I'll run it again in my terminal. And then you can see here that it basically, cat just displays the contents of, in this case, the file that we're passing in here. So this is the name of the file that was just generated. So I'm going to copy all of that, paste it into here, and then just give this a name for this SSH key. So in my case, I'm just going to do Tech Talk Demo because, again, I'm not currently using any SSH keys, so I do not need to worry about overwriting anything. Got a question real quick. If you already have an SSH key for GitHub, should you overwrite that for DigitalOcean? That's a really good question that I don't have an answer to about kind of the best practices for managing these. I think that you're able to create multiple SSH keys and then provide different services with those keys kind of as needed, but I'm not entirely sure. I can look that up and provide an answer after this, but I don't think I have a good recommendation to make from that perspective right now. So we've provided the SSH key, and you can see here it was saved. And now that's going to be saved to this machine so that it can immediately identify my connection coming from my computer. I'm going to leave the defaults for the rest of this. It's just asking how many droplets we'd like to create and to give it a name. I don't particularly need to set up many servers. We're not going to horizontally scale this. It's just going to be a very simple website. So just one droplet with the default name is fine. And then I'm not going to worry about backups for now. So I'll hit create droplet. And then what's happening now is that DigitalOcean is provisioning this machine. So it's going to, whatever process goes on over there, they're going to set up this computer or this virtual machine and then assign it an IP address that we'll be able to then use to connect to it. So this helpful progress bar showing us how far along we're making, and cool. It wrapped up and assigned this machine an IP address. So that means we can kind of go on to this next step. So our next step now is that what we're going to be working on, now that we have this virtual private server that we can connect to via its IP address, is to take some security steps and precautions that we should take to lock this machine down a little bit. So as we mentioned before, we're going to use a firewall to disable traffic to this server, except for SSH, which again is the tool that we'll be using to remote into this machine's terminal. And then we'll also create an unprivileged account so that we can access this machine without using the default super user that's enabled on all Linux machines. This is an important security step to take because you typically want to obey the principle of least privilege. So you can use an unprivileged account that can then elevate its permissions when needed to do specific system administration tasks. So we're going to follow those steps. And to do that, I'm going to copy the IP address and I'm going to connect to our VPS. So the command to connect to a machine using SSH is just SSH. We're going to give it a username. By default, that's going to be root. And again, this is that super user account that we're eventually going to get rid of. Switch that back. And then we're going to tell it the address of the server. So this was just that IP address that DigitalOcean provisioned to this machine. And when I hit enter, you're going to get a message just saying that the authenticity of this machine can't be established. Do you trust it? Basically, this is asking, are we okay connecting to this machine since we haven't done that in the past? And I'm going to say yes. And I need to provide now that passphrase that's locking my SSH file. I don't know if that's actually coming through on the Zoom screen share, but basically I just received a prompt from my operating system just saying, hey, something is trying to access your private key. Can you provide the passphrase you set up earlier to actually enable this? And so that's what I did. And then you can see here that my terminal prompt changed. So now we're connected as root. And then that crazy name is that host name that was set up by DigitalOcean for this machine. So now, even though we're in the same terminal window that we started off on from my computer, now we're actually connected to our VPS and can start to configure it. So the first thing that I'm going to do is to add that unprivileged account that I'll be using moving forward to connect to this machine. And the command for that is just add user, and then the name of the account that we would like to create. So in this case, I'll just use my name. And just asking for a password, so I'll provide that. And then just some details about me that aren't really relevant, so I'll just hit enter and set all this to blank. So now I've created that user, and then the next step is I want to be able to have this new unprivileged user be able to request escalated privileges to do system administration tasks. And the way to do that is to add this user to what's called the sudo user group on this machine. And the command for that is usermod with these two flags set, the name of the group, and then the name of the user. So that step is done. The final step that we need to take in order to be able to connect to this machine under this new unprivileged account is to move the public SSH key that we originally saved to the VPS when it was created over into this unprivileged account. So we're literally just going to copy that public key from the root folder, the root SSH folder, into the Ido SSH folder, and that will let us then connect to this machine as Ido moving forward. And the command for that, you have to, it's not just a simple copy and paste. There are some important permission settings that also need to be moved over. So we're going to use rsync for that with an archive flag. We're going to change the owner here of this file to me. So that's Ido user, Ido group as well. And then we're going to basically move over everything in this SSH folder to my user account. And it looks like it wasn't happy about that. I'm sure I've just got a typo somewhere. So let's see what I did there. Ah, I put this period in the wrong spot. There we go. No errors means a good thing. And so to test that that actually worked, I'm going to disconnect from the session, and you can just hit Control-D to do that, at least on a Linux. I don't know what the command would be on a Mac, but on my computer it's Control-D to disconnect that connection, and then we can reconnect to it as this new account that we just created. So previously we ran SSH root at IP address. I'm going to change that to Ido instead. And then you can see here, terminal has changed again. Now we're connected to this machine as Ido and are no longer connected as root. One thing that we can check really quickly to make sure that we actually did give this user permission to run as sudo is to run a sudo command. So I'm going to run sudo apt-get update, and just to make sure that this actually worked. And it did. So this is indicating that my user, which is typically unprivileged, has a way to escalate its permissions to run system admin commands. So I'll just clear all that out. And we're well on our way to securing this machine. Our next steps are going to be to start configuring our firewall. And we're going to lock down all the traffic to this machine aside from SSH, which is currently what we're using to connect to this machine. So we don't have anything set up with HTTP yet. As we add that functionality, we'll open up those parts of the firewall so that basically it's only allowing whatever functionality we want at any given point. So UFW is the name of the software firewall that comes by default on these machines. So if I try to run UFW status right now with my unprivileged account to see what's currently set up with this firewall, it's going to error out. And this is what we were talking about before with basically running under an unprivileged account. It's saying, error, you need to be root to run the script. So we have to explicitly take the step of adding the sudo command in front of it in order to be able to interact with UFW. So by doing that, we do get a response back. It's saying that the firewall is inactive. So right now, basically it's wide open. And what I'm gonna do is first enable SSH traffic, and then I'll enable the firewall. Because if we don't do it in that order, if we just turn on the firewall right now, I think by default, it's going to close all connections, which means we'll basically be locked out of our server and not be able to make much more progress from there. So the first thing we'll do is we'll make sure that it's allowing the traffic that we want. So the command for that is, and don't forget sudo, it's UFW allow, and then the name of this protocol that we want to be able to enable. So I'll run that. And then I will enable the firewall. And hopefully we don't get brutally disconnected from the session by doing this. So, and again, we'll run sudo. It's giving us a warning that, hey, doing this may disrupt your existing connections. Do you want to proceed? I'm going to say yes. And cool. Firewall is active. It's enabled on system startup. And we still appear to be connected to the server. So that is a good sign. The final steps that we can do, just in case we're super paranoid about security, is to actually disable the root account. So by default, every Linux computer that is set up is going to have this root account, and it's a good practice to limit access to it or just straight up disable it if you don't need it, just to make sure that anyone potentially trying to take control of your machine has kind of one less entry point to taking over it. So to do that, we have to edit a configuration file. And because it is a kind of protected configuration file, we also have to run it with sudo. And then we'll use Vim as a text editor. I am not a Vim expert, so for those of you who are, you're going to see some very bad Vim use here, but it will at least get the job done. So running this just opened up this configuration file, and we can look for permit root login, which is a very helpfully named setting that basically says, can root access this machine or not? And we're going to turn that off and basically set it to no. So let's see, change that to no, and then I'll save this file. And that's not going to take effect until we restart the SSH service. So I'm going to go ahead and do that just so that we can test that this one change that we made actually worked. So I'll restart that. Oops, missed one line there. Okay. And so just to confirm that that worked, I have disconnected from the machine, and I'll try to run the same command that we initially ran to connect to it, which was with root. And now when I do that, you see that we are getting an error message. So permission denied. We basically can't connect to this machine as root anymore. So we'll go ahead and jump back in as our unprivileged account. And we see that we're good. So awesome. We have successfully turned on the firewall, created an unprivileged account, given that unprivileged account a way to escalate its permissions, and disabled root to help further lock down this server. So some next steps that we're going to take is I'm very quickly going to install Node, because we're going to be running an Express app, which is written in JavaScript. So we need to get the Node runtime installed on this computer in order to be able to run Node applications. So to do that, let's run some quick commands here to grab Node from the software repository. Hopefully this doesn't take too long. Okay, that wasn't too bad. And then we'll need to run one other install, which is for npm which I've been told doesn't actually stand for Node Package Manager, but is still a convenient way of thinking about it. So we're going to get that up and running on here as well, so that we'll be able to get Express and some other dependencies that our little app has built. So go ahead and run that. I think NPM is quite a bit bigger, so this might take a little while. While that's all running, I have this simple app that is up on GitHub, and this is what we'll kind of deploy to our virtual private server. It doesn't have much going on with it. If we look at this package.json, you'll see that there's really only one dependency, which is Express. And in the app.js file, which is what we'll be using to kind of run this code, all that it's doing is using Express to serve static assets from a public folder. So I have just an index.html file in this public folder, and all that we're going to use Express for is to serve that file. Obviously, Express is much more powerful than just that, but just to make sure that I wasn't also demoing my awful web development skills, I decided to just make sure that we're only showing one file here. So we can see here, NPM is still running. It's taking a minute. Almost done. Then once it's done running, we will clone this repository to get all of the code over to our VPS so that we could actually run it. Almost there. It's the best when, there we go. Stuck at 99%. All right, clear all that out, and then very quickly we will grab our code. So with GitHub, you can grab the URL for the repository really easily. So we'll go ahead and copy that, and then just run git clone, provided this URL. And then we can see here that it cloned the repo and copied it over, which is great. So now we can move on to the next step over here. Looks like I jumped a little bit ahead of myself. So after we're done with this step, we'll have this virtual private server that we can connect to via an IP address securely and be able to run an Express app. So we've installed Node, we've installed NPM, and now we've used git clone to copy the app over to the server. And we can confirm that by running ls, which will show us the contents of the current directory that we're in. And we'll see simple express, which is the name of my repo. So I'm going to change directory to go into it. And we'll again just be able to see the very same files that were running before. And at this point, we can quickly do a sanity check to make sure that we can connect to our app. And so there's a quick question about the firewall, and that's a great question because we're going to need to configure it to allow traffic to our app. So let me open this up again. One thing to quickly note is that in my file, I'm going to be running this Express app on port 3000. So the firewall, if we wanted to be able to hit this app directly, needs to be enabled to allow traffic through port 3000 in order for this to actually be able to get hit by the internet. We're only going to do this temporarily. This is not the way that we're actually going to set up this whole environment, but at least as a way to check that things are working, we are going to enable port 3000 traffic to come through. So if we look right now at our firewall status, you can see that the only thing that it's allowing is OpenSSH. I think that this v6 stands for IPv6 as opposed to IPv4, but I can't confirm that. But what's nice about OpenSSH is that it has some kind of pre-built configuration that it has exposed to UFW to say, hey, if somebody enables my protocol, it's going to know which ports to open up. So in this case, the port that we want to open up is port 3000 for our little app. So I'm going to enable that. I think it's allow, actually. Let me run that. We can see that the rule was added. And if we rerun the command that we did before, so prior to this, it was just showing OpenSSH. Now it's also showing 3000. And if I run the app now by running node app.js, which is the same thing that you would be doing on your local machine, getting this error right now because it can't find the module, and it's because I didn't rerun npm install. So I've got to make sure that Express is actually available on this machine. So now if I run node app.js, we're getting this awesome confirmation message that it's running our app, which is what we expected to see here. Here's the actual code that got ran once we start listening. What we can do now is take the IP address, go to our browser, paste that in there, and I'll try to hit port 3000 on this machine. And when I do that, you can see that it did something. So we're not getting an error message. My browser isn't complaining. We're getting what clearly looks to be a website, and this is in fact what my index HTML is supposed to do. So at this point, we can hit this using an IP address over a specific port as long as this app is actually running. So not production ready by any means, but at least we can kind of see, hey, all right, this is generally working, or at least it seems to be. So obviously, if I close the app, so right here, I just hit Control-C to shut it down. And if I try to refresh this now, we're going to see a different result. Unable to connect. So there's nothing listening on port 3000 on this app. Totally done. Users see this, they never want to go back to our website again. So we'll fix that problem. But the other thing that we should do is to close off the firewall as we start to secure this even further. So we're gonna close off that port 3000 rule that we just enabled in order to do this quick test. So we're on sudo ufw delete allow 3000. It's telling us that the rule was deleted. We can confirm that by looking at the status again, and we can see that it looks just like what it did before with the OpenSSH, and not that port 3000. So even if we were to run our app right now, if we try to go back to this website, we're still going to get a problem. It's going to be slightly different. Right now, my browser is just kind of spinning and thinking it doesn't really know what to do, but it definitely isn't going to be able to hit our app anymore because we've closed off port 3000. So we'll stop that experiment and shut this down and move on to our next step. So the next part of this, you can kind of do a lot of this in whatever order you want, but one step that we're going to want to probably take if we're putting a website online is to give it a domain name. So typically what you need to do is register your domain with what's called a DNS registrar, which is a company that lets you say, hey, for mywebsite.com, any traffic that goes to mywebsite.com should go to this specific IP address. So it's a way to give our VPS a nice friendly name that people can actually remember and hit. As you guys know, you go to launchschool.com, not whatever IP address Launch School has for whenever you're trying to hit it. So to do that, I scooped up a domain. I just did imidom.com. It was available. So I went to Google to do that. There are a bunch of different companies that let you register domains. DigitalOcean is not one of them. But you can use DigitalOcean to manage your domain name. So there's some kind of funky processes that you can follow in order to move a domain to a different company to manage it. But in this case, we're just going to stick with Google here and give our domain a way to point to this IP address that we've been using this whole time. So I've signed into my Google account where I can manage my domain, and then I'll hop over to this DNS section. And again, all that we're doing is kind of, telling the internet as a whole where it should point traffic that's trying to hit imidom.com. And the way that you do that is through these, what are called A records. There are a whole bunch of different types of records here. I do not understand what all of them mean, but at least in order to route traffic from a domain to an IP address, you want to use this A1. And we're going to have to set up two A records. This first one that has this funny @ symbol is what represents just imidom.com. So there's nothing in front of it. There's no www or subdomains or any of the other kinds of things that you can put in front of that kind of root domain. It's just going to be this @ symbol. And all that it's asking for is a time to live. So this is just kind of a caching thing where it's going to say, yeah, this record is valid for, in this case, by default, 1 hour. And then the IP address that represents our server. So I'll go ahead and copy that one more time, paste it in here, and hit add. You can see here that it saved the change, but it may take up to 24 hours, or I'm sorry, 48 hours for the change to actually be reflected. Hopefully, as we go through this, it'll be much faster than that. In my experience, it does not take that long, but I guess it's just a quick way to protect themselves, as these changes do take a minute to propagate. So we might have to periodically check on this to make sure to kind of see when did this change take effect. And then the other A record that we'll create is the one for www. And this one represents, again, www.mydomain, which is imidom.com. And we give it the same exact IP address. So we'll hit add. Cool. Both of those are saved. They're now propagating their way throughout the world's DNS name servers out there. And so hopefully eventually we'll be able to actually hit our server at imidom.com once these changes have taken effect. So we'll go back to this. We finished pointing the name servers of our domain to the IP address. What we could try to do is to hop out of this connection, and just to see, maybe it did take effect really quickly, we could try to connect to our server now using imidom.com instead of the IP address. I don't think this will work quite yet, but we can at least give it a shot. Okay, it looks like it might have actually worked. So it's saying, again, we're getting this warning about the authenticity of the computer that we're trying to connect to, imidom.com. Now, because we're using a different name to refer to this computer, my computer is saying, hey, do you trust this new thing that you're trying to connect to? But then we can see here this IP address that's also associated with it. And that is the same IP address that we put here, which is our server's IP address. So it looks like those changes might have actually propagated at this point. And so now I really don't have to worry about this IP address anymore. imidom.com has kind of officially been registered as pointing to this server. So that is a helpful thing to get out of the way. And clearly that did not take 48 hours, which is nice. Otherwise, this would be a very long tech talk. So the next step that we're going to take back over here is to set up Nginx. And so jumping back to this diagram up here, Nginx is going to serve as both the web server that's going to be kind of listening for requests from the internet that had made it through our firewall. And it's going to be a reverse proxy. So when it gets that request, it's going to be responsible for routing that request to something else. In this case, that something is our Express app, but that's all that reverse proxy functionality means in this context, is it's just going to redirect the request to the appropriate place. So setting this up is really straightforward. We're going to, once again, update our software repository to make sure that we've got the latest versions of software that's available to install. And then we will go ahead and install Nginx. Now, there are a bunch of different web servers and reverse proxies that are out there. Nginx seems to be kind of a default. It's supported by Apache. It's free. It's open source. It seems to be super production ready. So it's probably a good default option. And DigitalOcean has fantastic tutorials for setting it up, a lot of which I use to help put this together. So we've just installed Nginx, and the next thing that we need to do is to enable traffic to basically interact with Nginx from the internet. And the really cool thing about this whole ecosystem of Nginx and UFW, and what we'll see later with Let's Encrypt, is that these tools were built to work with one another. So we can run a command here called sudo ufw applist, and it's going to tell us the different types of applications that have done something with the firewall to say, hey, you can configure us to manage certain types of traffic, and you don't have to memorize the ports that you need to enable. You don't have to manually allow them through the firewall. It just says, hey, if I enable Nginx HTTP, then that's going to allow HTTP traffic to hit Nginx, which is really nice, because otherwise I would be constantly looking up that HTTP is port like 22, whatever it happens to be, I forget. So, or port 80 rather. So we will go ahead and allow HTTP traffic by running sudo ufw allow, and then just the name of this configuration option that Nginx made available to us. We're going to start off with just HTTP and change this a little bit later. Rule was added. We can confirm that real quick by running status. And cool, we can see that now in addition to OpenSSH, we've also got Nginx. So next step, we can confirm that Nginx is actually running. And so to do that, we can run the system control command, which is going to let us check on the status of different processes that are running on our computer. So when I run that, yep, we can see this helpfully highlighted in green message that it is active and running. I imagine if it wasn't, we would get a much scarier and urgent color, but green is good in this case. So I'm going to go ahead and hit Control-C to jump out of that. And now we have to start configuring Nginx. So that's going to mean telling it to expect traffic from the domain that we set up, which was imidom.com, and then telling it what to do when it gets a request for imidom.com. And what we'll want it to do is to just redirect that request straight over to our app. But we have to tell it kind of how to do that. So to do that, we'll need to start with editing some configuration files. Now, these configuration files, from what I understand, can get pretty complicated. And there are best practices for following them. I'm going to go with the easy route and just edit the default config file. But if you look at the materials that we'll share after this, and what DigitalOcean recommends in their tutorials is to actually create different files for different potential websites that you're running on the same server. So we're going to take a little bit of a shortcut here by just working with the default file. So we'll jump into that one. Again, we have to edit it as a sudo user. I'm going to jump into Vim again as our text editor. I'll apologize again to anyone that actually knows how to use Vim, because this might be a painful thing for you to watch. And then I'll open that file. So we need to make two changes here. One of the first ones, let me scroll down, is to tell our server kind of what traffic to expect. And so this is where we're going to give it those same domain names that we set up down here. So basically this @ which represents imidom.com, and then this www version which represents www.imidom.com. We'll just replace this underscore with those two server names. I'll go ahead and save that change. And what's really nice about Nginx is you can somehow test your configuration file as you're making changes without actually implementing those changes. So the only way that Nginx is going to pick up what we just changed is to restart it. But before we do that, we can run this command to make sure that we didn't introduce any typos, we didn't forget any semicolons, that, you know, the whole host of things that can go wrong when you're messing with these types of files. We can run Nginx with this T flag, and it'll confirm that the syntax is okay, which is great. So it looks like it did say that the changes are good. So we can go ahead and reload Nginx now. Oops. Reload. This is just going to restart that process, and now it should have reloaded with the changes that we made. One thing we can check is we can try to hit our server now. So as we saw before, imidom.com did actually start working. It let us SSH into our machine. So it looks like those changes did take effect. So if I run this now, cool. We can see that we're connected. We've got that scary lock sign without it, which is saying that we're connected to it over HTTP. We'll fix that later. And then we're seeing this welcome message from Nginx. So we've got some indication that this magical stuff that we're doing over here on the terminal is resulting in changes, since Nginx is clearly getting a request from this domain name that we've set up. So always nice to be able to test these things as you're making the changes. I know for myself, with Linux, it's been a little difficult not being able to actually see things with the terminal. So I always like to find ways to verify that. So the next step that we're going to take is to go back into that config file. So I just hit up on my keyboard to go to previous commands. And we're going to want to tell Nginx to route requests to our app. So I'm going to copy some quick config information here. And what we're going to do is replace this location block with information about our app. So I'm going to delete this and paste in these changes. And if I was more competent at Vim, I would scoot this over, but this isn't going to cause any problems. So I apologize for this indentation that looks so painful to look at. But this is basically going to say that, hey, anytime somebody hits the root of this server, which is just what that slash represents, pass the request on to whatever's running on port 3000 of the local host. And if you remember, that's what we've set our app to do, is to run on port 3000. And then it's going to provide just a few more headers. I don't think that these are explicitly necessary for what we're doing, but this is a way just to potentially use like WebSockets, I believe, as opposed to just a normal HTTP request response cycle. So with our simple app, that's totally unnecessary, but doesn't, I guess, hurt to put that in there. But that's definitely something, if you were doing this, you'd want to verify. And so now what's going to happen is any request that hit Nginx will get pushed on over to localhost 3000, which is hopefully where our app will be running. So I'll go ahead and save this and then do the same thing I did before, which is confirm that the config file is okay by running Nginx with this test flag. And it's saying, yep, you didn't mess up. So that's encouraging. So then I'll go ahead and reload Nginx one more time. And now what we can do, if we try to hit this, it's still not going to do anything. Oh, actually it will. So we've now told it to do something with that request as opposed to just providing that default message and saying bad gateway. And hopefully why we're seeing this is because our app isn't actually running. It's not listening for any requests on port 3000. So why don't we try to run it manually and then see if Nginx will correctly take the request and hit the app. So I'll just cd into it and run the application. It says it's running. And cool, you can see here by actually running it, by actually having our app running on port 3000, the configuration that we set up on Nginx to route requests from root to port 3000 is working. So we have made a little bit of progress there by putting our app behind a web server and a reverse proxy. Not quite done though. Still have a few more steps to take. So let me make sure I'm on the right bullet here. Okay. So our next step is to set up PM2, which was the process manager that we talked about. And what this is going to do is just make sure that our app is always running. So if the server is up and running, our app will be up and running. If the server restarts, our app will restart. If our app crashes, it'll restart. So it's going to save us from having to do this process where we're remoting into this computer, changing directory into the directory for our app, and then running it, which is huge pain. So we're going to quickly install PM2. Just copy, I can type that one in. So PM2 is an NPM package, so we're going to install it as a global dependency by putting in this G flag. And there are, again, many different options for this as there are for web servers. So PM2 is by no means the only process manager. I'm pretty sure you can also use just a default Linux functionality to set up processes to run when the server starts. But this seems to be a recommended way of approaching this, and it provides some very easy commands to use. So we're going to go ahead and run with PM2 as our choice of process manager. So we've installed it. And the next thing we have to do is to tell it to run our app. So the command for that's really straightforward. It's just PM2 start and then the name of the file that it should kick off, which in this case is just app.js. And again, we're in our repository for this code base, which is why we can just run it like that. And we can see a whole bunch of stuff. This awesome art, whatever, text art, which is great. And then down here we can tell that, all right, cool, it's running the app that we created. So the next step that we need to do is to tell PM2 to start up whenever system D starts up. My understanding of system D is it's kind of like the process manager for Linux. So this is a way to confirm that PM2 runs whenever the system is up. And what it does is it provides you a command that you have to copy and paste. And the reason why it can't configure it itself is because you can see it has this sudo in front of it. So it needs those escalated privileges that only our account has. So I'm just going to copy that and run it. And that will actually set up PM2 to run when the system comes online. Now, the final step for this is to save these changes that we've made. So I'll hit PM2 save. That's successful. And I'm pretty sure now that we should just be able to hit this, and we can. So PM2 is now fully managing our little app. Whenever our server is up, our app should be up. I did not run, node app.js to handle this. This is now just being run by PM2. And one thing that we can do is try to reboot the server, which will obviously kill the application because the whole computer is going to go offline, and see if PM2 will correctly kind of start up and start running it. So let's give that a shot here. I think the command is just reboot. Yep, that booted me off the server real quick. And then let's see if I can refresh this. Now it's going to take a minute for the server to come back online, same way that it takes a minute for our laptops to come back online after a reboot. So we'll see kind of how long this takes here. You can also see if it's back online by going here. Okay, so it looks like the server is back online, but yep, I think we were kind of catching it right as it was spinning up there. So there was an error message there really briefly. The system clearly came back online. Nginx started running. PM2 didn't have a chance to start this back up yet though, but we can see here that we restarted the server and our application was able to get up and running. So these are great steps. We're almost done. So right now we are hitting the server just from HTTP. The very last thing that we can do for free with these awesome tools that are now available is to give ourselves an SSL certificate so that we can secure our website and hit it via HTTPS. So very straightforward steps to doing that. We're going to use Let's Encrypt and their tool certbot. So first we have to install certbot, and to do that you have to add a software repository. I don't think this is just a default thing that you can install using those apt-get commands that we were using before. So first we'll add the repository. And then we'll install certbot. I guess. And then the next step that we'll take is to enable HTTPS traffic through our firewall. So earlier, we only enabled HTTP. And so you have to explicitly allow HTTPS traffic to come through. So we can check this out one more time. We can see here we just have HTTP available. So instead, we want to allow both HTTP and HTTPS. So we're going to enable full, which basically just gives us both of those. And then we can remove our HTTP rule because it's redundant now. This Nginx full configuration kind of covers it. So no reason to clutter up our firewall rules by having redundant ports allowed. And so now if we look at our status, cool. We've got SSH, which we'll always need. And now we have Nginx full, which represents both HTTP and HTTPS. So now we can use certbot to issue ourselves an SSL certificate. So the command for that, it has this flag for Nginx. So this is awesome. It's going to basically configure Nginx for us to use this certificate. We're not going to have to do any additional work there, which to me just sounds incredible. From what I understand, this used to be a really, really painful thing to manage. So we're going to use the same domains twice again. So imidom.com and then this other version that has the www in front of it. It's going to ask for an email address. So certificates expire. They need to get renewed. There are other things that could presumably go wrong. So this is asking us for a way to get contacted. So I'll give them my email. Some terms of service we have to agree to. So I'll just hit accept. You know, asking if we want to get some emails from them. I'm just going to hit no for now. And then it's running the tests and the setup that it needs to actually issue the certificate to us. So that process is running and is kind of a mystery to me. I'm not entirely sure what it's doing, but I guess it's checking to make sure that, yes, this IP address for this domain is actually valid. I'm not entirely sure how long this should take, to be honest. When I did some test runs before, it wasn't too bad, but we don't get the handy, oh, it's cleaning up, deploying the certificate, and it's asking us one more question. So it looks like that did work, but now it's saying, hey, do you want to automatically redirect unencrypted HTTP traffic over to HTTPS, which is, again, the secure traffic? And I'm gonna hit yes for that. Seems like a good idea. Oh, looks like I hit no on accident. That's all right for the purposes of this, not a big deal. So it's saying, cool, congratulations. You just did a whole bunch of configuration with almost no work at all. We can do a quick test to make sure that it actually worked by running renew. And so certbot actually handles certificate renewals for you. You should never have to worry about it if it works, presumably. So you can try to renew it with this thing called a dry run. And it's just going to confirm that, yes, it can actually do that. And it looks like that all went through. And as a final check to see our little site, we can try to hit it from HTTPS. So, and it worked. So now we have, let's see what we're saying over here. So we've got a virtual private server. We can connect to it using a nice, easy domain name, using HTTPS securely, so only through the rules that we've enabled. We've got Nginx spun up as a web server and a reverse proxy that can route requests to our Express app, which is what's actually serving our website. And that is being run as a service by a process manager called PM2 so that it restarts whenever it goes down or crashes. And that's it. Now, obviously, there's, depending on the types of websites you have and if there's a database, and there's a lot more to getting things kind of production ready. But if you wanted to start from just a bare bones machine that's being managed for you by a cloud provider that can host a website, these are some of the steps that you can take. Any questions that I will do my best to try to answer? I'll definitely get back with a response to this SSH question about whether or not you should overwrite the ID that already exists if you're using SSH for a different service. But yeah, other than that, doesn't look like there are any questions. So thanks, I hope that was helpful. We'll find some way to share this kind of step-by-step with everyone if you did want to try to follow this yourself. If some of you are cooped up at home right now because of all the news, this could be a fun little weekend project, but thanks.